Okay, so this is how this for elastoplastic case. This is how this ground reaction curve looks. Okay, so now the question is when to put the support system and what should be the capacity of the support system. So before that, let me draw this thing again. So this is the same plot. So Saurabh, did you learn this thing in details in your rock mechanics class or?
Sir, about ground reaction curve and support curve.
Ground reaction curve?
Yes, sir, we were taught.
Okay, so you
Not,
remember everything,
not,
or is this are we adding something here, or?
sir, we were not told all these equations how to calculate. We were told like
Okay,
this is the graph and this is the support curve.
okay. So we are learning something, right? So now let's say this ground reaction curve looks like this. Okay, so this is our GRC, ground reaction curve. So similar to this, we have something called support reaction curve. So if you plot this thing, let's say before this, actually, I just want to explain something. Let's say this tunnel is getting excavated from left to right. Okay, and we are here, and like you are providing, let's say, stick. So this is the stick. So when this face is here, you put this stick, and it is just touching, this ground and the roof. Is this clear? What I'm trying to say? So this is our support, let's say. For example, simplest example is a stick, let's say, or maybe some probe or something like that. Okay. So what do you think when we just provide this stick or put this stick and the excavation is here? Do you think it will take some load, or it will like some load will be transferred here if we don't proceed this excavation? So what do you say? Will any load come to this support? Yes or
Can you
no?
repeat?
Sorry.
Can you repeat the last line, please? Network got disconnected.
So what I said is the tunnel. This is your tunnel. It is excavated from left to right, and when this face is here, so this is our face. Face of the tunnel means we are like up to here we have excavated. So A dash is our face. So this is our face, and this is our support. Let's say B dash is the support. So do you think we excavated up to this A dash face, and then we just put some kind of stick here, and let's say keep it for a couple of days? Do you think some load will come to the stick?
Sir, if deformation is not stabilized, then it will come.
Yeah, because there will be no deformation, there will be no load to the stick, right?
Yes,
But
sir.
if we excavate it further, and with the gradual excavation, this point B will move in downward direction, right? And we've excavated this one, first excavation, second excavation, third excavation, it will move gradually down, and then this will deform and it will take support, it will support this, this roof. Is this clear? So initially there will be no kind of pressure given by this, support when the face is at AA. But let's say it moved to C dash, or D dash, or E dash, then gradually this will be, the load will come to this support here. Is this clear?
Yes, sir.
So when this phase is at AA, this point B has already moved. So let me write it down. So when phase is at AA, AA dash, B, B dash support was installed. And when this was installed, there was already some vertical displacement at point P. Is this clear what I have written? Anybody who did not
Yes, sir.
understand? Okay. So, and this displacement is called, let's say, U0, and a displacement at B. Let's say that is U0. Okay, so you start with this point here, and then when this phase will be, when phase will move towards right, gradually the support, no, the point B will come down and support pressure will be given by the support. Is this clear? So when this phase will move towards right, the B will deform, like it will further go down, and the support will deform, and it will give some support pressure. So here there will be a pressure by this support. So maybe you can write PS. Okay, pressure by the support. Is this clear? Anybody?
Yes, sir.
Okay, now the question is, what is the slope of, so this curve here is called support reaction curve, because this is reacting, right? Like when tunnel is deforming, this support is giving this being provided to the tunnel boundary. Okay, now the question is, what is the slope of this line? First question is, what is the slope of support reaction curve, SRC? Okay, and second is, because see, if you put a thin support BB dash, after some excavation, maybe it will crush, right? If the thickness is not good enough, then it will crush, like it will break, the support will break. So what is this maximum support it can provide? Are these two questions clear?
Yes.
Anybody? The girls are not speaking. Let's see who is here.
Sir,
Yes,
sir, I have a question.
yes, please.
After excavating AA dash phase, then only we are getting displacement at B, right? Then, I mean,
Yeah,
how this line came, like when phase is at AA dash, BB dash support was installed, there was already some displacement, vertical displacement at point B.
yes. Already vertical displacement at point P. And that displacement which was already there when we put the support system is your UO.
Okay, so means there will be some displacement before AA dash excavation.
Yes, before this installation of BB dash.
Okay.
Okay, before the installation of the support, there will be some displacement at point B.
Okay, sir.
Okay,
Yes. Thank you, sir.
so yeah, so the question is, like this is very important here because the question is, when to provide this support system. Let's say you have some support system of a particular capacity. Then what you do when the phase is at this location, what is the, let's say this is our support system. Let's say this is our support. So up to what distance from this phase we will provide this support system? That is our question here. Okay, and how do you decide that? Is, let's say this is our support reaction curve. If you provide this, support very early, okay, so the support very early means your displacement will be very little, right? Maybe you provide this support very close to the surface, up to here, or maybe close to the face, sorry. So then what happens, like this ground reaction curve goes like this and it ends here. So what does this mean is this is not going to intersect with your ground, the support reaction curve is not intersecting with the ground reaction curve. Okay, so this is case one, let's say. One is SRC not intersecting with GRC. So what does this mean is, sorry, GRC. What does this mean is, like when you, this tunnel will further excavated, this, the support will break, like it is not going to, it is going to fail. Support will fail. But if it is, somewhere here, like you just allow some deformation and you just excavate it a little bit further. So the displacement will be there. So maybe you can start your, this, start putting the support system after some displacement, maybe with the same, support system, it can work. So this is our case two. So GRC is intersecting with SRC. Okay, so this is, like uh, this is your ideal kind of, situation, like where you have your ground reaction curve is little bit, uh, or maybe the support reaction curve is little bit above this ground reaction curve. And, here, if you draw a line, This deformation of the tunnel will be your final deformation. Is this clear? So it will intersect this ground reaction curve, the support reaction curve, and where it intersects, the whole thing will, like the displacement will stop. And this will be your final deformation of the tunnel. Is this clear? Okay, so there should be ideally some kind of factor of safety here. That's why it is intersecting, a little bit more. If that is not sufficient, then you change the thickness of the shotcrete, let's say. So that will make, the support reaction curve maybe a little bit, higher. Okay, so there are two things here. One is, what is the stiffness, let's say K, and what is this maximum support that can be provided. So I'll finish it in 2 minutes. Is that okay for you?
Yes.
Yes, sir.
Okay, so let's say for concrete lining or shotcrete lining, how do we get this K value? Okay, the slope of this line is given by this equation here. And for this, you need what is the Young's modulus of the shotcrete or concrete, what is the Poisson's ratio of the shotcrete and concrete, what is the thickness of the lining, and what is the radius of the tunnel, and what is the uniaxial compressive strength of shotcrete or concrete. Okay, so if the stiffness is a function of your, this Young's modulus of concrete, and other things, maybe it will, little bit depends upon your thickness of the concrete also, right? And radius of this thing. So, but it's directly proportional to your Young's modulus of the concrete or shotcrete. Okay, so once you know that, okay, I have a straight line going like this, and what is this peak value is given by PS maximum. So this PS maximum is your peak value, and given by half of sigma C concrete into 1 minus this thing, Ri minus TC square Ra square. Is this okay? Anybody who did not understand this thing? So if you want a higher peak PS maximum, then you increase this value of TC. Okay. So if you increase the value of TC, what is this TC? TC is a shotcrete thickness. So this is a tunnel boundary, and this is the shotcrete or concrete lining that you are providing. So this is your TC, thickness of shotcrete or concrete. Okay, so if you increase this TC, this PS maximum will increase. Is this clear? So just to repeat, you first for your tunnel get the ground reaction curve, how it is looking like without any support. Then see what is the support available. Let's say you have 100 mm thick shotcrete. Then you have all the properties of this shotcrete, right? And let's say for 100 mm thick shotcrete, it will have, you just calculate what is the stiffness of this thing, what is the slope of this line, right? And then you calculate what is this PS maximum. So you just bring this curve here, to know where it fits. So let's say if this is fitting here. So now in this case, there is too much, gap between this point and this point. So that means the shotcrete you are providing is too thick. So maybe you can reduce it to, 75 mm thick. Is this clear? Or maybe, you know, in the second case, maybe it is not just intersecting this thing. So you can delay this support installation time and then you can provide it here if you are okay with this much final displacement. So you can play with these things to, you know, stabilize the tunnel. And anybody has a question here, else we can stop. Please go through this. I'm going to ask some question from here. Okay. So I'm going to
Okay,
take a PDF of this and we'll upload it today. But this is a basic concept, like how we, you know, decide. We from RMR we had this, you know, like this, the time, right? We can see the time, but that is kind of, you know, some based on some empirical data, right? Like seeing how the tunnel around the world that behaves. But this is the real concept by which we can decide when to provide the support system. Is this clear?
yes, sir.
Okay.
Yes, sir.
Okay. Okay. Please try to go through the concept and you know, like what I was